intermediate COCOMO model. Now in this intermediate COCOMO model, the basic core of COCOMO remains the same. Only because of the change in technology and other aspects which has come, one more aspect which is EAF, this is the adjustment factor that has been added here or multiplied here. Okay, so the same basic equation for the COCOMO basic model is used, but 15 cost drivers, these are rated on a scale of very low to very high. See, these are 15 parameters and very low to very high to calculate the specific effort multiplier, and each of them returns an adjustment factor which multiplied it will yield the total effort adjustment factor. For example, you say that my software require a lot of reliability, strong reliability. So you are going to take, say, very high reliability. You are going to take this one, required software reliability. This is the product attribute, cost driver. So if you want very high reliability for your project, you will take the value as 1.40 in EAF. If there are multiple values you have to take in your project, if it is required, then you will take all the values and multiply it to get the EAF. It is simply the multiplication of these values being taken. In addition to this EAF, the model parameter A, this has slightly changed from the basic COCOMO model. Basic model, the values has been changed, but the parameter B is similar. So let me just show you again, because I have to show you the equation. This was the basic COCOMO equation, okay, for effort and time development. This one A1, A2, B1, B2. But in the second part of basic COCOMO, that is the second version, which is the intermediate, only A and B are there. A remains same, A is slightly changed, B remains the same. Okay, now the question is database system for an office automation project. The project is simply given as organic. A value is already provided to you as 3.2. B already provided 1.05. C is also there, 0.38. Now 4 modules to be implemented. What are these modules? Data entry 0.6 kilo data, this the delivered software instructions we are talking about. Data update, query, report generator, all these are there. But the system size is also given 3. Okay. Now what you are going to do here is, see, the cost drivers, the level, and EAF is already given. If it is not given, you have to use the table. That if it is complexity, it is required to high level storage, to high level experience, to low level, and programming capabilities or programmer capabilities to low level. This EAF has to be used. These are value. I showed you the table. So these are the value, and this will be corresponding to or will be coordinated with the EAF. Adjustment factor, effort adjustment factor. Okay. Now this is the expression of the intermediate COCOMO. E equals A KLOC to the power B multiplied by the EAF. This is effort adjustment factor. So what are the values of A and B? The value of A is slightly changed. The value of B remains the same. Okay. So since this project is organic, the time is like this. This time value is 2.5, which is the B1, and power is B2, which is different values. Okay. Sometimes in various books you will see this MMKORR. Don't worry, this is nothing but the effort. Sometimes you will see LOC, line of code. Somewhere you will see KDSI, that is the delivered software instructions. But the basic idea remains the same. Now these are the EAFs. These are the EAFs value. What you have to do, you just take them, multiply them together. Multiply all of them. Then you use the expression. So this is EAF already used. Now you have to put A here. We are just multiplying all of these, and this will come to 1.61 when we multiply all of these. 3.2 is already given in the question, and in the table also you see A is 3.2 for organic. What is the kilo line of code? See, the system size is 3 KDSI. So whether KDSI or KLOC, you are going to put it here, 3. And then what is the B value, the power B value for organic? It's given in the question also. You can use it here also. 1.05. So in organic, A will be 3.2, B will be 1.05. Put this in the expression here. What do you get? 3 raised to the power 1.05 will give you the value of 3.17. So you have this whole value is 1.61. 3.2 is already there. 3 raised to the power 1.05 is 3.17. And when you multiply all of these, you will get 16.33 mmKORR. Sometimes it is called as effort. Now let us come to the time of development. Now this is organic and you already have the table. So this is 2.5 E, effort raised to the power 0.38. Effort we just found out to be 16.33. So you have 2.5 multiplied by 16.33 effort raised to the power 0.38. And when you put it, you will get 7.23. And since it comes in months, so it is just over 7 months. Just over 7 months, or 7 months and a quarter of a month. Now how many people should be hired? And for that, this is very simple division. You divide the effort and the divisor will be time of development. So 16.33 divided by 7.23, which is the effort divided by the time of development, and that is going to give you the number of team members. So when you do 16.33 divided by 7.23, you will get 2.26. So it has to be greater than 2 team members, so around 3 members you will need.